Okay, welcome back. So let's see what happens when we have a period change. So if we take a look at this graph, example 3, our amplitude is 1. Okay, the absolute value of 1 here is 1. So let's take a look at periods. So 2 pi over base. So we have 2 pi divided by 1/2, which is essentially saying 2 pi times 2. And that gives us 4 pi. Okay, now we have talked about this in the past that when our period is bigger than the original 2 pi, which is the original period of the sine curve, then this would give us a horizontal stretch. Okay, so because it's bigger than that, it means it's moving slower. So it's going to take us more time to get through an entire cycle. So let's take a look at the original sine curve so I can graph this very quickly. So as you should be as well. So here's pi over 2, 0, down here at -1, 2 pi. And then if I was to continue on to 4 pi, okay, 2 pi, and then the next one here would be right here to 3 pi, continue on all the way to 4 pi. So the one that I'm just showing here in green, okay, and just going to connect the dots. All right, so there we go. So there is our original curve, not the best one. I'm still trying to get used to my little iPad pen here. Okay, so now we notice that my period is now 4 pi. Okay, so what that tells me is that this point right here now has to, my end point is now going to go all the way over here to 4 pi. So that means my function is going to go from 0 all the way to 4 pi. So when you guys are graphing, okay, and you want to set up the tick marks, okay, as I like to call it, for this graph, what I want you to do is start off with your beginning point. So sine always starts at 0. Then I want you to take your period and remember that period goes all the way at the end here at 4 pi. Okay, so then what you should think about is cutting it in half, because we know that sine has a one hill and then one valley, and the halfway mark is where it hits through the x-axis. So half of 4 pi is going to be 2 pi. Okay, so we're going to identify that halfway mark at 2 pi. Okay, now the halfway mark usually of the original graph is pi, and then between that is pi over 2. Okay, so now we need to figure out what is the halfway mark between 0 and 2 pi so that we can get our y max value, okay, which is usually 1. Okay, so the halfway mark between 0 and 2 pi, so half the distance there is going to be at pi. So I'm just going to put a tick mark here. Okay, I'm not putting a point, I'm just putting a tick mark here so that we can just identify that this is where we need to put a point. Okay, so halfway between 2 pi and 0 is pi, and we know that we need to put a y max point here at 1, okay, because my amplitude is 1. All right, and then that is going to start to give us our hill. Okay, all right, so now you can see our hill is elongated here. Okay, now we have to figure out, well, we know that from 0 to pi, okay, that's like the first quarter of our graph. Then we go from pi to 2 pi. So now I know that from 2 pi to I add another pi should be at 3 pi would be my next tick mark, or you can think of it as the halfway point between 2 pi and 4 pi. So if I did 2 pi plus 4 pi, which is 6 pi, and then divide it by 2, that's 3 pi, which happens to be right here where I have my tick mark at. Okay, and then I know that the y max should be down, or y min, I'm sorry, should be down here at -1. Okay, and then I can follow on with my graph here. Okay, so there's my sine curve going from 0 to 2 pi, and then 2 pi to 4 pi, my hill and my valley with no amplitude change. And then I could just, because I know it's an odd function, I can then do this on the other side of the curve. So halfway point is at -2 pi. It ends at -4 pi. And then I just know that I need to turn this the opposite direction, okay, which means it goes over the x and the y. All right, so at -pi, it's going to be down here. And then at -3 pi, we know it's going to be up here at the top. Okay, so I graph 2 full periods between -4 pi to 4 pi, and there's my sine curve right there. Okay, it's a beauty. All right, moving on, let's do another one. Okay, here's another one for us to take a look at. All right, and this one is going to be cosine of 4x. Okay, so let's take a look at what cosine 4x is going to give us. So again, our amplitude is 1. Okay, so we need to do the period. So 2 pi divided by 4. Okay, because the b value, remember, is directly in front of the x. So that's going to give us pi over 2, okay, or 1/2 pi. So obviously pi over 2 is going to be less than our magic number of 2 pi. So that tells us that there is going to be a horizontal shrink. Okay, that means this graph is moving much faster than the original graphs. Okay, so if I take a look here, cosine normally starts up with a y-intercept of 0, 1. Okay, it comes down to pi over 2, comes down here to -1 at pi, then back to 3 pi over 2, then 2 pi. Okay, and then I could just keep continuing on using the pattern that we already know. Okay, so they're in, I guess this is kind of like a pinkish red. I'm going to carefully use my pen here to plot. This is 2 full periods from 0 to 4 pi of the original cosine x graph. Okay, so now I'm going to come over here in like an orange color. Okay, and we are now going to graph our new one. Okay, so again, we're going to start because since my amplitude is 1. Okay, here's my beginning point. And then we want to remember that this 2 pi is now, think of it, we talked about this as kind of like Toy Story. It's always going into like a trash compactor. This 2 pi is now getting squished all the way into this pi over 2. Okay, so there's my end point now. Okay, so right here, this point right here, this pi, 2 pi, it got squished all the way to this pi over 2 point. So now what we have to figure out is what's going to be this halfway point between 0 and pi over 2. Okay, because this guy right here got pushed to here. Okay, and now we need to figure out, well, where's this halfway point that normally is at pi, now needs to get squished between 0 and pi over 2 perfectly. Okay, so what we need to figure out is, well, what's half of pi over 2? Okay, so maybe on the side here, you're thinking, okay, well, pi over 2, and now I need to cut this in half, okay, which divided by 2 is the same thing as multiplying by a half, okay, which is pi over 4. Okay, so that means if I come back over to here and I count, there's 4 blocks here. So that means right here, this tick mark is halfway. That's pi over 4. I now am taking this -1 and squishing it into here. Okay, so now you can kind of start to see I now need to take this value right here, which is another tick mark. Okay, so here's pi over 4. That's my midpoint. Now I need a value that's between 0 and pi over 4. Okay, so then that means I need to take another half of this to find out what that x value is. So that's going to be pi over 8. Okay, so that means this x value right here is pi over 8. And because I can't make this any smaller, okay, so that's pi over 8. And this is where the pi over 2 point is now going to pi over 8. Okay, so that means all of these is a pi over 8. So pi over 8, 2 pi over 8 reduces to pi over 4. So then that means this guy right here is 3 pi over 8, and it goes through right here. Okay, so we want to just, basically we're just playing with fractions. Pieces of pi here. I know this isn't the best drawing, and I know it's going to be hard because it's so small in here. And then what we're going to do is we're just going to try to get to 2 pi. So then here we're going to know that there's going to be a point here, point here, another point here to go to pi. Okay, so this is 3 pi over 8, 4 pi over 8. So this one would be 5 pi over 8, then 6 pi over 8, which you can reduce, 7 pi over 8, 8 pi over 8. Okay, which you guys would write in for me. So that's 8 pi over 8. So then 9 pi over 8, then 10 pi over 8, 11 pi over 8, 12 pi over 8, and 12 pi over 8 reduces to 3 pi over 2. All right, and then we're going to have 13 pi over 8, 14 pi over 8, which we can reduce, 15 pi over 8, and then 16 pi over 8, which reduces to 2 pi. So we know we did it correctly. So within the original cosine graph, we can actually fit 4 cycles into that one. And then that's as far as I would just have you guys go. And then you guys would actually label each one of these X value points. But because of my pen, I wasn't able to do that. But I was able to talk through each one of these X values. Okay, so literally we're just adding by pi over 8 every single time. And the graph itself is exactly the same. Okay, so that is how you would graph a period change. Okay, it's squished. All right, so then what I would like you guys to do is you're going to go to your Nearpod and you're going to graph the following function, cosine 1/3 x. Take a look at your amplitude and period and see what you come up with. Good luck.